In this video, I will show you how to find the volume of various shapes, including combinations of shapes such as these. In problem number 1, we're dealing with two separate prisms. So let's look at this as, I'm going to call this top 1 volume 1, and I will call the bottom prism volume 2. So let's find each volume and then add. So volume 1. The volume of a prism is just the area of the base times the height. Alright, so volume 1. So I like to find the area of the base first. I'm looking at the area of the base as being this rectangle, alright, that's like this. Okay, that's my base. And the area of a rectangle is just base times height. So that's going to be 18 times 8. Okay, which is 144. Okay, so that's going to go in right here. So I'm going to have 144 times the height of prism. Oh, you know what? I'm sitting here doing volume 2. Well, this is actually volume 2 that I'm doing, so I'm just going to change that and say volume 2. Alright, so this is volume 2, and this is volume 2 that I'm actually doing. Anyway, the height of this prism is 4 millimeters. So that means volume 2 is going to be 144 times 4. So that's 576. Alright, so that's volume 2. Now let's go ahead and find volume 1. And again, volume 1 is going to be the area of the base times the height. So for this prism, erase some of these extra lines, the base is right here. So again, it's a rectangle, so I'm looking at this as being the base. So I need to know the dimensions of that. Alright, so I'm just going to draw a little line here. So first I'm going to find the area of this base, and I see that this edge right here is length 8. That's going to be the same as this. I see that this edge right here is length 5. That's going to be the same as this edge. So that's why the area of this base is going to be 5 times 8, which is 40. And that's going to go right here. So volume 1 is going to equal 40 times the height of prism number 1, which is 5. So that's going to be 200. So volume 2 is going to be 200. Alright, so the total volume is going to equal volume 1 plus volume 2. Alright, so that's going to be 776 if I add these up. And looking at the millimeters, the volume will be millimeters cubed. Looking at problem number 2, on the top we have a hemisphere, and on the bottom we have a cylinder. Alright, and I am going to call this volume 1, and I'm going to call this volume 2. So let's start with volume 1. Volume 1 is half of a sphere. So the volume of a sphere is 4/3 pi r cubed. So I'm going to need to know the radius. Well, the radius is the same down here, so the radius is 4. Okay, that's the radius. So if this were a whole sphere, the volume would be 4/3 pi times 4 cubed. All right, but that would be for a whole sphere. This is half of a sphere, so I'm going to wind up taking half of this. So I'm going to put this in my calculator. So I'm going to have 1/2 and then 4/3 pi 4 to the 3rd power. All right, so that's 128 pi over 3. So volume 1 is 128 pi over 3. Okay, now let's find volume 2, the cylinder. Okay, so the formula for the volume of a cylinder is area of the base times the height. So first we need to know what the area of the base is. Well, the base is a circle, so that's pi r squared. So since the radius is 4, that becomes pi 4 squared, which is 16 pi. So that goes right here. So volume number 2 is 16 pi times the height of the cylinder. The height of the cylinder is 12, the distance between the bases. So that's 192 pi. Okay, so now I've got volume 1 and volume 2. So the overall volume is going to equal volume 1 plus volume 2. Okay, so I'm going to do 128 pi over 3 plus 192 pi. Okay, they're giving us an exact answer, 704 pi over 3. And the lengths are in inches, so this will be inches cubed. Or we can hit the toggle key and get the decimal. So that's 737.23. There are two ways to look at problem number 3. We've certainly got a cylinder here in the middle. So you could look at this as a cylinder and plus 2 hemispheres. All right, so clearly this is a hemisphere and this is a hemisphere. So I could approach this problem as volume 1, volume 2, and volume 3. And I could add all those up. Now, there's a slightly quicker way. And that is, if you look at the fact that we have 2 of these, all right, if I take 2 hemispheres and put them together, what do I have? Okay, these are 2 halves of a sphere. Together, they make a whole sphere. So I could look at this as simply a sphere and a cylinder. I could look at it as just those 2 things. One sphere split in half and combined with a cylinder. And that's the quicker way to do it, so that's what I'm going to do. Okay, so when I talk about the sphere, both halves, I'm going to consider this to be volume 1. And then the cylinder, I will call that volume 2. So volume 1 is a sphere. And the formula for the volume of a sphere is 4/3 pi times the radius cubed. The radius of the sphere is the same thing as the radius of this cylinder. That's 2. So the volume 1 becomes 4/3 pi 2 cubed. So that's 32 pi over 3. Okay, so that's volume 1. All right, that's both halves of a sphere put together as a single sphere. Now volume 2 is the cylinder. So volume 2, you know what, I better leave myself a little bit of space. The volume of a cylinder is the area of the base times the height. So let's take a moment and calculate the area of the base. Well, the base is this circle that has a radius of 2. The area of a circle is pi r squared, so that's going to be pi times 2 squared, so that's going to be 4 pi. So that's going to go in right here. So volume 2 is going to be 4 pi times the height of the cylinder, which is 6. So that's going to be 24 pi. So now I have volume 1 and volume 2. So the overall volume should equal volume 1 plus volume 2. Okay, so that's going to be 104 pi over 3. That's the exact answer. And since the units are in meters, this will be cubic meters. All right, or as a decimal, that's going to be 108.91. For number 4, we have a hemisphere stacked on top of a prism. So we definitely have a hemisphere and a prism. So I'm going to call this volume number 1, and I'm going to call this volume number 2. I will find each, and I will add them up. So let's start with volume number 1. Okay, look, the formula for the volume of a sphere is 4/3 pi times the radius cubed. Okay, so that would be 4/3 pi. Let's see, what is the radius of this thing? The radius goes like from here to here. Hold on, I have to do that slightly better. Okay, the radius is doing something like this. How big is that? Well, that's going to be half of the width of this edge right here. If this is 8, then this must be 4. Because if I kept going all the way to the other side, that would be the same as this edge down here. If this is 8, then this is 8. But if I'm doing the radius, that's half. So that's going to be 4. All right, so 4/3 pi r cubed becomes 4/3 pi times 4 cubed. So that would be the volume of a sphere, but this is only half of a sphere, so I'm going to take half of this. Okay, that's an equal sign. All right, so I'm going to put this in my calculator. So 1/2 4/3 pi 4 cubed. So that is 128 pi over 3. So there is volume 1. Now, how about volume 2? Volume 2 is a prism, and the formula for the area of a prism is the area of the base times the height. So let's figure out the area of the base. Well, here's the base right here. All right, so the area of this rectangle is 8 times 12. So that's going to be 96. I accidentally wrote 13 for a second. That was 12. Anyway, the 96 goes in for the base, and then the height is 8, so that's 96 times 8. So that's 768. So volume 2 is 768. So the total volume is going to be volume 1 plus volume 2. So that's 128 pi over 3 plus 768. So 902.04. And since the units are centimeters, this will be centimeters cubed. Number 5 is a prism. Notice that I've got a triangular base right here, and I know that's the base because I've got 2 of those, all right, across from each other. So these are the 2 bases. Now the distance between the bases is the height. So this distance right here that I just colored in green, just please understand that this is the height of the prism. Now, the formula for the volume of a prism is this. Volume is the area of the base times the height. So the first thing I need to do is I need to calculate the area of the base. Well, that's a triangle. So that's the area of a triangle is 1/2 base times height. In this case, this B stands for base. That's the base of the triangle. Okay, so I'm talking about this edge right here is the base of the triangle. And that's the same as this edge of the congruent triangle. So this is 16. So in other words, 1/2 base times height becomes 1/2 16 times 7. So the area of the base is going to come out to be 56. So keep that in mind. So now the volume is area of the base times the height. So that's going to be 56, all right, which I just got, times the height. And as I mentioned before, the height is 25 because that's the distance between the 2 bases. Doesn't matter that it's going sideways, that is the height. So if I just multiply 56 times 25, the volume is 1,400. And this will be cubic centimeters. Number 6 is another prism. So again, the base is a triangle. So notice I have a triangle here, I have another triangle here. These are congruent. These are the 2 bases. Okay, once again, the distance between the bases is the height. So just keep that in mind. This is the height of the prism. But look, the formula for the volume of a prism is area of the base times the height. So the first thing we have to do is figure out what is the area of the base. Well, a triangle, the area of a triangle is 1/2 base times height. So let's see. Here I'll use this triangle right here. Here's the base, and here's the height. So the base is 15, so this is going to be 1/2 15 times. Now, what's the height of this triangle? Well, they mentioned in the problem that it's 12. So that's 1/2 15 times 12. That's not 1/2. Let's try that again. 1/2 15 times 12. 90. So that is the area of the base. So that's going to go right there. So now the volume of the prism is going to be 90 times the height, meaning the height of the whole prism. So that's 20. Okay, that's going to be 1,800. And since the units of length are centimeters, volume will be centimeters cubed. Number 7, many bricks have cylindrical holes in them. If the radius of each hole is 1.5 inches, what is the volume of the concrete in the solid part of the brick? All right, the volume of the concrete that's left after you remove these 3 holes. Well, the volume of the concrete is going to be the volume of the whole prism. So I'm going to say volume prism minus the holes, all right, minus the volume of the holes. Okay, if I start with the volume of the solid prism, like looking at it as a solid box, and then if I subtract the 3 holes, then that's going to leave behind the concrete around it. Okay, so let's start with the volume of the prism. The volume of a prism is the area of the base times the height. Okay, so this is going to be the area of the base times the height. What is the area of the base? So this is the base right here. Okay, or that's one way I can look at the base. But what is that going to be? So that's just going to be base times height. So that's 3.5, and the height is 2.25. Okay, so I'm finding the area of the base here, and that's 3.5 times 2.25. Okay, so the area of this base is going to be 7.875. Okay, so that's going to go right here. So this is going to be 7.875 times the height of the prism. Now, understand the height of the prism is always going to be the distance between the 2 bases. So I've got this rectangular base here, and I've got another rectangular base here. And this red line is the distance between them, so that's the height. Okay, so this is the volume of the whole prism. So it's just this times 8. So that's 63. Interesting. So I get 63 3 for the volume of the prism. Now I need to subtract the volume of the holes. Okay, now the volume of a cylinder, all right, because each hole is a cylinder. All right, let me clean this up a little bit. So the volume of a cylinder is also area of the base times the height. Okay, so that's also area of the base times the height. But look at one of these holes. All right, the base is a circle. All right, so if I want to find the area of that circle, that's going to be pi r squared. But what's the radius going to be? Okay, well, they told us that. The radius of each of the holes is 1.25 inches. So that means the area of each of these bases is going to be pi times 1.25 squared. Okay, so 1.25 squared in fact, I think I'll just go ahead and type in pi 1.25 squared. Because I'm going to get a decimal anyway, you know what I mean? Boom. So 4.91. Now, that's the area of the base of a single hole. So that is going to go right here, all right, 4.91. The area of the base times the height. The height of the cylinder is the same as the height of this prism. It is 2.25 inches, so 2.25. Now, let's pause and be careful for a minute. So far, I've just been dealing with one cylinder. All right, base times height, that's just a single cylinder. There are 3 cylinders. So instead of just subtracting base times height for a hole, I need to subtract 3 of these. So I don't have to do it 3 times, I just need to put a 3 in front of this. So now I've tripled the amount of hole that I'm subtracting. So I just need to put a 3 here because there are 3 holes. Okay, so this is what I need to do. All right, so I've got 3 times 4.91 times 2.25. Okay, so that's 33.1425. Okay, so if I subtract these, that should be the volume of the concrete. Okay, so that's 29.86. And this is volume, so I'm going to have inches cubed, cubic inches. So this is the answer for number 7. All right, problem number 8. A cylinder has a volume 1,764 pi cubic inches and a height of 25 inches. What is the circumference of its base? Interesting. Exact or approximate form. So we've got this cylinder. Okay. So here's my little schematic of a cylinder. So they mentioned volume. So hey, the formula for the volume of a cylinder is the area of the base times the height. Okay? So we're given the volume. So that is 1,764 pi. The area of the base we don't know what the radius is or anything like that. So all I can do for the area of the base is I can put pi r squared. That's the best I can do. And then the height of the cylinder is 25. So times 25. So my first step is going to be to solve this for the radius. Let's find the radius. Okay, so I'm thinking let's divide both sides by 25 pi. All right, that'll get rid of the pi and the 25. Okay, 25 pi. So that gives me, notice that the pi's are going to cancel out. So this is going to give me the radius squared. This is not going to go in evenly, but let's just see what happens if I do 1,764 divided by 25. Okay, 70.56. Maybe I can work with that. 70.56. So now if I want to find the actual radius, I'm going to need to take the square root of both sides. And that should give me the radius. .4. Okay, that's nice and simple. So the radius is 8.4 inches. Okay, so that was all very natural, but now it's time to use this to find the circumference. All right, the circumference of a circle, that's like the perimeter of a circle, but the formula for it is 2 pi times the radius. But I now know what the radius is. So now I can say that the circumference will be 2 pi times 8.4. So I'm ready to say what the circumference is. Okay, 2 pi 8.4. Okay, that's 52.78. Okay, and circumference is a length, so that would just be in inches. So this would be the approximate form. Just for fun, if I wanted to write an exact answer, here's what I would have to do. I'd have to leave pi out of it for a minute. Okay, here's another form. If I just do 2 times 8.4, that's going to be a short decimal. Okay, 2 times 8.4. That's 16.8. Okay, yeah, we could have done that in our heads. So that's going to be 16.8. And then we didn't do anything with the pi, so the pi will still be there. All right, so this would be the exact form of the answer. But I figure as long as you're going to have decimals in there, you might as well go for it. Last problem. A pyramid has a square base that is 39 feet long on each side. The volume of the pyramid is 21,294 cubic feet. What is the height of the pyramid? Okay, so I am not an artist. So if I try to draw this pyramid, it's not going to go well. I can just tell you right now. Okay, the pyramid is something like that. This is a square base, so we're looking at 39 by 39. Okay, and they gave us the volume, and we're supposed to find the height of this pyramid. You know what? I guess there's supposed to be another length like that. Okay, yeah, that looks a little bit better. Anyway, since they're giving us the volume, let's start by writing the formula for the volume of a pyramid. The volume of a pyramid is 1/3 the area of the base times the height. So let's put in what we know. We know the volume, so we know that 21,294 is equal to 1/3. Okay, next comes the area of the base. Well, the area of the base is this square right here. Okay, this is the base right here. So the area of that square, okay, is 39 times 39. 39 squared, if you will. Okay, that's 1,521. Okay, so I can go ahead and use that in the formula, 1,521, because that's the B, that's the area of the base. Okay, great. I'm betting 3, 8, 9. This number is divisible by 3, so it would be nice to just go ahead and multiply by 1/3, basically. So if I do 1/3 times 1,521, I get 507. So now I have 21,294 is equal to, what did I say? 507 times the height. So if I want to know what the height is, all I have to do is divide both sides by 507. All right, because these will cancel each other out. And then that'll be it. $42, look at that. A nice whole number. And these units are in feet. So this is a length, so it will also be in feet. So that's the answer to number 9. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.